Fantastic, fantastic, right? So this is chapter number 6, brakes, right? So again, we'll cover it in the point of view of your ETL exam, right? So again, there is not much theoretical portions available in brakes, right? Whatever you're going to study today, even in clutches or in brakes, not much theoretical things will be there, right? So what will be there is mainly numerical portions, but we will see what kind of numerical can be asked. We'll at least have an overview of all different things that can be asked, so that whatever is being asked, you should be able to answer. Okay, so let us start with brakes. Okay, so if you see brakes, what are the different classification of brakes, right? Brakes can be classified into mechanical, electrical, pneumatic, hydraulic on the basis of the actuation power. So where the actuation of the brake is available. So it could be mechanical, means I'm mechanically applying some force by my hand or by my feet or whatever, right? It could be electrical, you are pressing a switch and electrical motor is running, which is actually causing the brake to run, right? It could be pneumatic, where you are using air, right? Air to transfer the power, right? Or it can be hydraulic, where you are using some kind of hydraulic fluid, right, to transfer the power, right? So this is actuation power, where the actuation power is obtained from, right? Apart from that, again, if you see all 4 types of brakes, mechanical, electrical, pneumatic, hydraulic, can be classified into radial and axial, right? So what is radial brake? Radial brake is a brake in which effort is perpendicular to the shaft. Effort is perpendicular to the shaft. Okay, this is what we are going to see. Okay, this is what we are going to see, right? Radial brakes, right? This is generally used in the cars. Okay, then the radial brakes will be there in the cars. Okay, then we have axial brake, right? Axial brake, in which the effort is parallel to the shaft. Generally, we get to see this in bikes, right? We call it disc brakes or caliper brakes, right? So disc brake, if you see, there will be disc. Okay, there will be a disc. This is the shaft. This is the shaft, right? Whenever you apply the force, the force will be acting perpendicular to the, sorry, parallel to the shaft. This is the direction of force, actuating force, effort. This is the direction of effort, right? Whereas in radial brakes, if you see in radial brakes, suppose this is the shaft is coming out of the board, right? Effort is perpendicular to the shaft. Effort will be in some this direction. So if you see, effort will be perpendicular to the shaft, right? So you're going to see it in detail. Okay, not all. What is there in our syllabus is shoe brake and brain brake, right? And band and block brake, but you need not go through band and block brake. If you just go through shoe brake and band brake, okay, that is good enough. So this is what is covered in your GATE syllabus. So we are doing as per the GATE syllabus, because HL exam is also asking. It is mentioned that the syllabus will be that of GATE. Okay, so let us try to understand. What exactly is a brake, right? All of us know what is a brake. Is a machine element whose function is to retard a moving member, right? It is a machine element whose function is to retard a moving member to bring the moving member into stationary condition and hold the member at rest, right? Okay, all of us know this. Physical ki baat hai. A brake performs this function using a frictional force, right? This is something important. How the brake performs, it uses a frictional force. So one of our motive in the questions will be to calculate the frictional force, right? Applied on the moving member by using a shoe, right? By shoe. So what I'm telling is, okay, it could be a shoe or it could be something else, right? If you're studying a shoe brake, right? If you're studying a shoe brake, there will be a shoe, and this is the moving member. moving member. So there will be some kind of friction which is applied by the shoe on the moving member to stop it. Let us try to understand. Okay? Let us try to understand. Okay. So what is going to happen? Suppose this is a moving member which is rotating, as you can see. The moving member is rotating, as you can see, rotating in the clockwise direction. In which direction? It is rotating in the clockwise direction, right? So initially the shoe will be disengaged. Initially, what will happen to the shoe? The shoe will be disengaged. It will be at some upper position. Okay? It will be at some upper position, right? But as you want to break it, what you are going to do? You are going to press the shoe. As you want to break it, what you are going to do? You will press the shoe, right? We'll apply some force. This force is nothing else but the effort. This force is nothing else but the effort. This is nothing else but the effort. The effort you are putting, right? You will apply some force, and because of this force, some amount of friction will be generated here. Some amount of friction will be generated here, right? Some friction will be generated here. So the friction, what a friction is going to do, the friction will retard the motion of the moving member. The friction will retard the motion of the moving member. So what is important to learn here? Okay, this is something which we can all figure it out ourselves, but what is important to learn here is what is the direction of the friction on the moving member and what is the direction of friction on the shoe, right? So if you see, if this is the direction of the moving member, the direction is the clockwise, as you can see. So friction force will be opposite on the moving member. Yes or no? The friction force will be opposite on the moving member, right? And by Newton's third law of motion, who is applying this friction force on the moving member? The shoe. Who is applying this friction force on the moving member? Who is applying this friction force on the moving member? The shoe is applying this friction on the moving member. The shoe is applying the friction force on this moving member. So what will happen by Newton's third law of motion? Every action has equal and opposite reaction. The moving member will apply an equal and opposite friction force on the shoe. Right? I've shown this separated, but this is happening while in engaged position. This is happening while in engaged position. I've shown it in separated, but this is happening while in engaged position. This is happening while in engaged position. Okay. So if the radius of the moving member, that is r, if the radius of the moving member is r, so what is the braking torque achieved? Can I say the braking torque achieved is friction multiplied by the radius r? The braking torque achieved is friction multiplied by the radius r. Okay, so our whole problems will be based on this simple concept. Our whole problems will be based on this simple concept. Okay, so let us try to see how does a shoe brake look like. So this is a shoe brake. As you can see, this is a shoe brake. Okay, this is how a shoe brake looks like, right? So this is the wheel, which is the moving member, right? Wheel, which is the moving member, right? This is the wheel, which is the moving member, right? So this is the brake handle. You can say this is the brake handle. This is the brake handle, as you can see. This is the brake handle, right? Okay. So this is the P, which is effort. So when I apply some force P, what is going to happen, right? Some amount of normal reaction will develop here. Some amount of normal reaction will develop here. Some amount of normal reaction will develop here, right? This will be there in both. This will be there in both. Okay, some amount of normal reaction N, on the lever and some amount of normal reaction on the wheel also, right? Equal and opposite, equal and opposite. Then friction force will be there. Friction force will be there on the moving member. The friction force will be in this direction. On the moving member, the friction force will be in this direction. Sorry. Friction force, let me say F. On the lever, the friction force will be in this direction. Right? There's something that you will have to figure it out. It is not necessary that the wheel will be rotating clockwise always, right? So if it is rotating anti-clockwise, you'll have to figure it out. So first figure it out for the wheel. It will be easier for you to figure it out for the wheel. Wheel, if it is rotating clockwise, definitely the friction force will be opposite, right? No doubt about that, right? And yes, there might be some force in the hinge. Okay, so the lever can be hinged at three positions. Generally, there are three types of questions where the levers are hinged at three positions, three different positions. Means I have drawn it in the same figure, but it will be hinged either at O1 or at O2 or at O3. I'm telling or, right? I'm not using the term and, right? It will not be hinged simultaneously at more than one position, but it might be hinged at O1, it might be hinged at O2, it might be hinged at O3, right? So these are the three types of questions that you might have. These are three types of questions, numerical questions that you might have. You might be given that it is hinged at O1, it might be given it is hinged at O2, you might be given it is hinged at O3. So if it is hinged at these different directions, right, the equations will become different. The equations, right, because you have to take moment about the hinge point while solving the question. You have to take moment about the hinge point. The equations will become different, right? But that part, I think you'll be able to solve it. It is on the lever. The hinge will be on the lever, right? Because the lever can move up or down, right? You're applying force on the lever, right? The wheel will be fixed somewhere. Okay, there will be a shaft here and there will be bearings. The wheel will be fixed, right? So this lever you can see, the lever you can see, the lever you can see, lever has the shoe attached to it. The lever has the shoe attached to it, right? The lever has the shoe attached to it. The lever has the shoe attached to it. The lever has the shoe attached to it. This is shoe, right? The lever has the shoe attached to it, right? So what is hinged is the lever. The lever is hinged, okay? So that you can grab it using your hand here. You can grab the lever using your hand. You can grab the lever using your hand. You can grab the lever using your hand, and then you can press the wheel. You can press the wheel with your using your hand or feet, whatever you want. Okay. 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 So now in shoe brake, if you have to draw the FBD, generally you have to draw the FBD of the lever. किसका FBD बनेगा? लीवर का. Let us see. Let us see. Let us try to take an option. ठीक है, एक को solve करते हैं. ठीक है. If I solve one, the others are easy. Let me take the condition. Let me take the condition that it is hinged at O3. Let me take the condition hinged at O3. Hinged at O3. Okay, this is the hinge point. This is the hinge point. Okay. Now let us see what exactly is going to happen. So the FBD will be made of the lever and the shoe. FBD किसका होगा? FBD, the free body diagram of lever and shoe, right? Not of the wheel, not of the wheel. Okay. So if I take moment about, okay, if I take moment about, now all of us know one thing, that what will be the frictional force? Frictional force is equal to mu into n. The frictional force will be equal to mu into n, right? Now, if I take summation of moment about point O3, it should be 0. Why? Why summation of moment about point O3 should be 0? Because the lever is at equilibrium, right? It is not moving. Is the lever running out of your hand? No. Is the lever running out of your hand? No. Right? So lever is a stationary condition. Initial velocity, final velocity, everything is 0, right? So I can say the lever is at equilibrium. So I can apply the equations of equilibrium, right? The equations of static motion, right? Statics. So I can say the summation of the forces about O3 is equal to 0. So if you do that, you can see there are three forces here. Okay? What I can say is P into L plus B, P into L plus B, right? P into L plus B. This is a clockwise movement. P is causing a clockwise movement, you can see, minus N into B, because N, the normal reaction, is causing a anti-clockwise movement. You can see it very clearly, isn't it? N is causing a anti-clockwise movement, P is causing a clockwise movement. Can you tell me what kind of movement is friction causing? What kind of movement is friction causing? Tell me. Tell me guys, what kind of movement is friction causing? Is it a clockwise or anti-clockwise? It is a clockwise, right? About this point, you can clearly see it is a clockwise movement. About this point, you can clearly see it is a clockwise movement, right? So if clockwise means I'm going to use plus. There is no as such rule that clockwise has to be positive, anti-clockwise has to be negative. I simply assumed here that clockwise is positive is equal to 0. So if you want to find out the effort, the effort will be NB minus FRC divided by L plus B. This is how you can find out the effort. So एक ही equation लिखना है, ठीक है? एक ही equation लिखना है. This is what the equation is, right? This is what the effort is. ठीक है? This is so simple. इतना simple. I think that this brakes chapter is the simplest in your machine design. ठीक है? Even with respect to gate point of view. ठीक है? Nobody should miss. There is no theoretical questions, only numerical questions. That numerical questions are also so very simple. Nobody should miss. Okay. Now you can see something here. It is a very interesting concept. Why I have taken this only. Okay. In gate classes, we'd have explained you all each and every points, right? But here I have taken only one concept because I want to answer a objective question, probable objective question also. Okay. Now if you see here, the friction force is is actually helping us to break the system. It is actually helping us to break the system. How? You can see clearly, the more the friction, you can very clearly see it, more is the friction, it is getting subtracted, right? The friction force is getting subtracted, so less will be the effort required. More is the friction, less will be the effort required. More friction implies less effort required in this case. It will not be always. It is not always. Only in this case. Which case? Hinged at O3. Which case? Hinged at O3. Okay, it is only in this case. Hinged at O3. Okay, so this kind of brakes are called self-energizing brakes. This kind of brakes are called self-energizing brakes. Why? What is the speciality? Right? Because the moment due to friction act in the same direction as that of moment due to effort. You have seen this is also positive, this is also positive. Both of them are clockwise, right? Moment due to friction acts in the same direction as that of the moment due to effort, right? So the friction force helps in breaking the system, right? The friction force helps in breaking the system. Definitely, ऐसे तो friction help ही कर रहा है. Without friction, we will not be able to break the system, right? Right? or simply we can say friction force reduces effort. Friction reduces effort, right? Friction is definitely, it is friction which is helping us to break the system. Without friction, we'll not be able to break it, right? We'll not be able to break, right? Okay, but one thing that needs to be, so every brake should be designed by hinging it at O3. Every brake should be designed by hinging it at O3. No, it is not feasible. Why? Because many times the self-energizing brakes will also self-lock itself, or might become uncontrollable, right? It might self-lock itself, or it might become uncontrollable when, I'll tell you here itself, when it can become self-locking, right? You just see this self-locking, okay, self-locking. Now friction force can be written as mu into n. Friction force can be written as mu into n. So this formula can also be written as n, I am taking common, n I am taking common, so it becomes b minus mu c divided by L plus B. B minus UC divided by L plus B. So if mu C becomes greater than B, if mu C becomes greater than B, so what is going to happen? You will require no effort to break the system. You'll require no effort to break the system. This is called as self-locking. This is called as self-locking. Now, have you been to airport anyway? If you've been to airport, this is generally phenomenon. Common people can see it in airport. There are other examples also. Okay. Have you been to airport? If you go to airport sometimes, if you see the trolleys, that carries your luggage, right? If you go to airport sometime, if you see, you just closely look at the trolleys that carries your luggage, right? They are actually self-locked. You'll not be able to move these trolleys initially, in initial condition, because they're self-brake. Only when you press the handle and you release the brake, only when you press the handle and release the brake, only then you'll be able to move the trolley. Right? This is a very common example a common man can view, right? So if you happen to go to a airport next time, just go see the trolley, right? They are at a self-locking positions initially, right? Only when you press the lever and unlock the brakes, right? Then only the trolley starts moving. Okay, so it is not that self-locking is not at all useful, but you have to be, if you are not very sure about the friction and about all the dimensions, you might not be able to design a self-energizing brake. You might not be in a position to design a self-energizing brake, because it might result in a self-locking or uncontrollable brakes. Okay, so here the questions can come from self-locking or self-energizing brake. You should be careful, right? Is it okay? Shall we move on? Is it okay? Shall we move on? Okay. So okay, we'll do questions also towards the last. ठीक है, questions भी करेंगे, तो एक ही बार में थोड़ा सा theory जो है simple है, let us complete it. ठीक, so band brake, ठीक है, this is the second kind of brake, that is band brake, and this is a simple band brake. This is a simple band brake, right? So the rotation of the wheel, you can say, is in this direction. The rotation of the wheel is in this direction, right? So what will happen, and I'm putting the effort in the upward direction. So what I'm doing is I am holding this and I am pulling it up. I am pulling it up. What I'm doing, I'm holding this and I'm pulling it up. So once if I pull it up, so what is going to happen is the tension will develop in the strings. Right? And because of this tension, what is going to happen? There will be some friction. Some friction will get generated. And because of the friction, there will be a torque, that is a frictional torque. There will be frictional torque which is going to actually stop the moving member. Okay, which will actually stop the moving member. So let us try to see. Okay. Now can you tell me, can you give me an idea which will be greater? T1 is greater than T2 or T2 is greater than T1? Which one is greater? T1 or T2? देखते हैं, simple logic. ठीक है, just looking at the figure you should be able to tell which one will be greater. T1 is greater or T2 is greater? Which one is greater? T1 is greater or T2 is greater? Looking at a question, you should be able to answer which one is greater. T1 is greater or T2 is greater? Which one is greater? T1 is greater, T2 is greater. Yes, good. Guna, what about you? It is T1, right? It is T1. How to tell? Very simple. Thoda sa observation. If you observe it a little bit, you'll be able to tell it, right? See, this is rotating in this direction. So this string is being pulled. This string is being pulled. So if there was no friction, the thing is that if there is no friction, T1 will be equal to T2. For no friction case, for no friction, generally we study it in mechanics, right, where we ignore the friction and weight of the pulley and the string. For no friction, T1 is equal to T2, but because of friction, because of friction, what is going to happen is, T1 will be greater than T2, because you can see, because of friction the string is being pulled this side. The string will be pulled. The wheel will try to pull the string down. Whereas you can see the wheel is trying to push this spring up. Definitely it will not get pushed, but you can see the difference. This string is being pulled down, this string will be pulled down, and this string will be pushed up. So what do you think, what is going to happen? Which one will be greater? T1 will be greater than T2. T1 will be greater than T2, right? So there are two formulas here. बहुत सिंपल है फॉर्मूला, आपको इतना याद रखने की भी जरूरत नहीं है. द ग्रेटर ऑफ द टेंशन डिवाइडेड बाय स्मॉलर ऑफ द टेंशन, T1 by T2 is equal to e to the power mu theta. E to the power mu theta, where mu is the friction, coefficient of friction, and theta is angle of wrap. Please make sure that you remember this, it is in radian. Angle of wrap in radian. Okay, what is angle of wrap? You can see it is the how much angle the string has wrapped the moving wheel. Okay, so it might be 180 degree, it might be more than 180 degree. It is dependent on how the strings are oriented. It might be less than 180 degree, right? It might be less than 180 degree. So we'll see one problem we are doing, okay, which is where it is more than 180 degree. Okay, we'll do a problem, we'll get to see. When you see the figure, you'll get to realize. Okay, अभी दिखा लेते हैं आपको. Okay, let me show it to you. Yes, you can see here, right? It is dependent, the angle of wrap is dependent on how the arrangement of the strings you have done. So can you tell me what will be the angle of wrap here? Can you tell me? Even without looking at the equation, okay, you can say that it is 3 times 90. Okay, the wrap, where is the wrap? How much the strings have wrapped the wheel? This much. So what is this angle? Yes, what is this angle? Yes, 270. But you have to use it in radian. So you have to use it in radian, that is 2 pi by, 3 pi by 2. 3 pi by 2. ठीक है, always make sure that you are using it in radian. So ठीक है, देखते हैं. ठीक है, what is the second equation that needs to be used? This is equation 1. This is our first equation that we are going to use. This is the first equation, my dear friends, that we are going to use. What is the second equation? The second equation is very simple. ठीक है, second equation is very simple. ठीक है, the total torque, total moment about a hinge point should be 0. Here this is the hinge point O. So moment about point O should be equal to 0. So moment, to find out moment, I'm drawing the FBD of the lever. Okay, please make sure what you are doing is that you are drawing the FBD of the lever. So how many forces are there in the lever? Okay, how many forces are there in the lever? Right, there is T2 in the downward direction. If you see the lever, okay, I'll draw it a different color pen. Okay, if you see the lever, this is the lever. What are the different forces? P in upward direction, T1 in the downward direction, T2 in the downward direction. Now T2 is passing through point, that is the hinge point. T2 is passing through the hinge point. If I take moment about point O, if I take moment about, in this case, if I take moment about point O, so T1 into B should be is equal to P into L. L minus B plus B, N minus B plus B, so it will become T into L. So this becomes your second equation. So from equation 1 and 2, you can find out what is T1 and T2 both. From equation 1 and 2, you can find out what is T1 and T2 both. Okay, so इतना ही करना है, बैंड ब्रेक में इतना ही करना है, there is nothing much. ठीक है, there is nothing much. ठीक है, yes, the hinge point might change. ठीक है, let me say take another example. Here the hinge point is different. ठीक है, all of you try, at least try to form the equations. What will be the two equations? The first equation is common for all. T1 by T2 is equal to e to the power mu theta. Okay, this is common equation. Try to form the second equation. Okay, try to form the second equation. How? Take this as O. So second equation is summation of moment about point 2 equal to 0. All of you try to form the second equation first. Yes, T2 into A. पूरा लिखो, पूरा fast. At least you put it on copy. Okay, you might not uh, uh, write it in the chat box. What you can do is you can put it in your copy, so that when I rewrite the equation, okay, you should be able to compare whatever you have written, and you should be able to verify if whatever you have written is right. You should be able to verify whatever you have written is right. So now what we are going to do? We are going to write the equation of moment about point O, right? So you see again, the FBD that you are going to draw is that of the lever. Okay, this is the hinge point O. T1 will be pulling the lever downwards. T1 and T2 will be pulling the lever downwards, and the effort P, you can see, will be pulling the lever upwards. So if you do take a moment about point O, okay, very nice. T1, T2 into A plus T1 into A plus B should be is equal to P into L. So this is our second equation. T2 into A plus T1 into A plus B is equal to P into L. Right, very nice. Okay, so from equation 1 and 2, you can actually solve for T1 and T2. 1 and 2, you can solve for T1 and T2. From equation 1 and 2, you can solve for T1 and T2. So simple this is. Right? Just basics clear ho, then nobody should miss equation from this. Okay, now again, the first equation is same. Take the first equation is same. Write it down once in your copy, the first equation. Write it down, because writing will give you the confidence, right? We'll be able to remember the formulas only if you write down the equations again and again, again and again, again and again, again and again. Okay, so first write down the equation. Write down both the equations. The first equation is T1 by T2 is equal to e to the power mu theta. Right, this is equation number 1. The second equation, again moment about point, the hinge point is 0. T1, about which point you're taking the moment? थोड़ा सा about the hinge point, right? About the hinge point. Please cross check once whatever you've written. Okay, about hinge point, if you see, if you draw the FBD, if you draw the FBD of the T2 is in this direction, T1 is in this direction, therefore P is in this direction. So if you take the hinge point is somewhere here. This is A, this is B, and this will be total distance if this is L minus B, right? Okay, so if you take moment about a hinge point, that is O, right? You can see P and T2 are producing anti-clockwise moment, isn't it? P and T2, P and T2 are producing anti-clockwise moment, right? And T1 is producing clockwise moment. So what can I write it as? Okay, I can write P into L, right? Total this distance is L, this distance is L, P into L plus T2 into A, T2, and the distance from the hinge point is A, and distance from the hinge point is A, is equal to T1 into B, right? Because T1 is producing clockwise, the effort P and T2 are producing anti-clockwise, so both of them will be opposite. So I'm pretending this distance is B, right? So you can rewrite this as P into L is equal to T1 minus B minus T2 into minus T2 into A. So you can see here the tension T2 is helping us to reduce the effort. To reduce the effort. So that is why it is known as self-energizing brake. It is known as self-energizing band brake. Okay, self-energizing band brake. Okay, so band brake, this is self-energizing band brake. Self-energizing band brake. Okay, so band brake, what you have studied? You have studied simple band brake. This was simple. This was simple band brake, right? When the hinge point is O, right? Then you have studied differential band brake. Okay, differential band brake, right? So how is the differential band brake helpful? The differential band brake is helpful because it helps in stopping the right wheel, right? It has more power. Actually differential band brake will have more power. ठीक है, anyways ठीक है, इतना हमें डिटेल में हम लोग नहीं जाएंगे. ठीक है, we are just bothered about equations right now. ठीक है, so differential band brake, it will not be at a hinge point. ठीक है, and you'll have differential self-energizing band brake, third condition, where the hinge point will be between T1 and T2, where the hinge point will be between T1 and T2. Okay, so Try to solve this question. We'll do two questions, one from Sue brake and one from band brake. Okay, we'll do two questions, one from Sue brake and one from band brake. Try to solve this question, all of you, fast. So first, okay, the rotation has to be given. Okay, rotation, let me say it is rotating in this direction. Rotation has to be given. Let me say it is rotating in this direction. Okay. So first, decide the frictional force, direction of the frictional force on the wheel. Then you can decide the direction of frictional force on the shoe. You can draw the FBD of the lever, right? From the FBD of the lever, you'll be able to solve it. From the FBD of the lever, you'll be able to solve it. Okay, देखते हैं. Very nice. So let us see, let us go through. Okay. So definitely on the wheel the friction will be on this side, on the wheel the friction will be on this side. That was why on the lever the friction will be on the shoe, the friction will be on this side, right? If you draw the shoe, okay, if you draw the shoe, this is the friction, and there will be some amount of normal reaction also. So if you want to, if you draw the, I'm not drawing it FBD separately, ठीक है, इसी में समझ लेते हैं. और if you want to draw, you can draw, इसी में समझ लेते हैं, ठीक है. So we are considering the FBD of the, we're considering the FBD of the lever, ठीक है. So friction को we are simply writing as P. Let us write it as F. Friction, let us simply write it as F. Let us write friction as F. Now one thing I know, what are the dimensions given? Let us see. Dia is given as 300, means radius of the drum is equal to 150 mm. Absorbed torque. What is the torque? Torque is given as 75 Newton meter. Coefficient of friction, mu is given as 0.35, right? The pressure in the block is uniform. Calculate the force P. So you need to calculate the force P, right? So torque is given, right? So we know the torque. The torque will be applied on the wheel, right? To stop the wheel, to stop the wheel, the torque applied by friction will be how much? Can I say it is friction multiplied by the radius? Torque is equal to friction, frictional force multiplied by the radius, right? So you can calculate the friction force here because the torque is given and radius is given, that is 75 Newton meter divided by 150, that is 0.15 meter. So how much it is coming out to be? Let us calculate. Equation will verify, Naveen. Very nice. Okay, I think your equation seems to be right. Okay. Equation is right, in fact. Okay, that equation is right. So we are doing the other calculations. Okay, 75 divided by 0.15 is equal to 500. To 500 Newton. So what is the frictional force? Frictional force is 500 Newton. Can you calculate normal reaction from here? Normal reaction will be frictional force divided by mu. That is equal to frictional force divided by, what is the mu? 0.35. Point divided by 0.35. Coming out to be 1428.57. 1428.57. Answer will be Newton. Right? Now, Now let us do whatever you have done, Raveen, right? Let us take summation of moment about 0.2 should be equal to 0. Let me say this is 0.2, right? So if you see direction of movement of the force and friction, they are same, that is clockwise, right? Direction of movement of force and friction is clockwise. Direction of movement of the normal reaction is anti-clockwise, about 0.2, right? So what to do, how to write the equation, let us try to write the equation. So frictional force, or let me take effort first. Or that is a force P is equal to P into how much is the total distance from the hinge point, that is 450, right? P into 450 plus friction force F into what is the distance of the friction force, that is equal to 50. You can see, okay, 50 it is given as 50, right? 50 minus, I can do minus n into 200, or simply I can say is equal to n into 200. You have the values, substitute the values, you can find out P is equal to 200 into n minus 50 into F divided by how much, 450. Calculate it and give me the answer. 200 into n, what is n? 1428, 1428.57 minus 50 into F is 500, okay, 260714, okay, divided by 450, ठीक आ रहा है, 200 into 1428.57 minus 50 into 500, okay. How much you're getting the answer as? 579.36. I'm getting the answer as 579.36. Effort P is equal to 579.73. 579.36 Newton. Okay. So is it clear to everybody? Let us go through the next question. इसको try कीजिए, all of you fast. At least try to get the equations. How you are going to solve it. So to find out maximum tension, so again, let me give you the direction of rotation. Let me say this is direction of rotation, anti-clockwise. यही direction होगा if force is in this direction. So this is how it will be the direction of rotation. Yes, you can find the torque directly. See, torque, to find out the torque, ठीक है, to find out the torque, ठीक है, you'll require both the maximum torque that can be completely brake. Okay, no, you cannot directly find out the torque on the wheel. You have to find out. Okay, it is not the torque on the lever. Okay, you just read the question once properly. The maximum wheel torque that can be completely braked. Right, to find out the maximum wheel torque, you have to draw the FBD of the wheel. If you draw the FBD of the wheel, you get to know, right, there will be some amount of friction here which is equal to T1, and there will be some amount of T2, and this is the center, this is the radius, right? So in that case you will be able to find out the wheel torque. Wheel torque is slightly different. Right, first you have to find out T1, then you have to proceed on to find out T2, then you'll be able to find out. Right, the first question is maximum tension that can be generated. Let us first write down what is the data given. The wheel has a radius of 200 mm, so radius is equal to 200 mm, right? Theta is equal to 270 degree, that is equal to 3 pi by 2, right? That is equal to 3 pi by 2. Okay, the braking force applied to the drum is, okay, this force is given, the braking force is 100, and the coefficient of friction is given as 0.5. Maximum tension. So to find out maximum tension, to how, what we can do is to find out maximum tension, draw FBD of lever. To find out the maximum tension, draw FBD of the lever, right? So this is tension T1, this is tension T2, right? If you draw the FBD of the lever, right, and then use summation of moment about point O. If you take summation of moment about point O should be equal to 0, I can directly say 100 into 2 meter should be is equal to T1 into 1 meter. So from here you can find the value of T1 is equal to 200 Newton. T1 is equal to 200 Newton. This is the answer of the first part. This is the maximum tension that can be generated. The maximum tension that can be generated. Okay. Okay. So now if you draw the FBD of the wheel, if you draw the FBD of the wheel, right? This is T1, this is T2, right? Now, what is the angle of rep? We have already seen the angle of rep is 270 degree, right? This is the angle of rep, theta is equal to 270 degree. Now, can you find out T2? We have an equation to find out T2. We know T1 by T2 is equal to E to the power mu theta. T1 is equal to 200 divided by T2 is equal to E to the power mu is given as how much? 0.5 into 3 pi by 2. So this implies, let us calculate T2 first. What will be T2? E. Yes, definitely not possible to ask for objective question, okay, without calculator. But let us at least try to understand. If you do a question of this type, we will be able to see if other varieties of question. You might be asked the formula, or you might be asked something else. Some data might be given. Okay, so that's why we are doing it. 3 pi by 2, 0.5 into 3 pi by 2. Okay, 200 divided by. So T2 is coming out to be 18.96. 18.96 Newton. Let me cross check it once again. E to the power 0.5 into. Okay. So what is the braking torque on the wheel now? What can I say? Braking torque on the wheel. Braking torque on the wheel, I can say it is equal to, torque is equal to, right, T1, torque on the wheel is equal to T1 minus T2. Or you can say, you can see body force. Body force, one is clockwise, the other is anti-clockwise. So I can write braking torque. We simply write it this way. Braking torque T1 into R minus T2 into R, that is equal to T1 minus T2 into R. How much? T1 is 200, 200 minus 18.96, 181.04 into R. What is the value of R given? R is, I think it is given in the question, yes, 200 mm. 200 mm, if I convert it into meter, is 0.2. 36.21. 36.21 Newton meter. Okay, 36.21 Newton meter. Is it clear? Is it clear to all of you? Okay, so that's all in brakes. Okay, that's all in brakes. Now we'll move on to see. This was a very simple chapter. ठीक है, आप बस इतना ध्यान रखिए. You should know what are the different types of brakes: shoe brake, differential brake, right? And simple problem, if they ask the questions like it has been seen, they are asking T1 by T2 is equal to, right? T1 by T2 is equal to, you should know this formula. You should know this formula, right? It has been seen that question about self-locking and self-energizing brakes have been asked in engineering service also. Okay, in engineering service also, right? But numerical questions are rare, right? Simple numerical questions might be given. So once you have done this question and you have done this question, you need not worry about any numerical question from brakes. Okay, you should be able to answer. Okay, you should be able to answer. Okay, now let us enter into clutches. Now let us enter into clutches. This is our last chapter, clutches. Okay, so all of you go through this small definition. Okay, all of you go through small definition, and then I'll explain you how exactly a clutch works and what exactly is the requirement of a clutch. What is the requirement of a clutch? Okay, sorry, I went for a water break. Okay, can you hear me, all of you? Can you hear me? Okay, fantastic. So, what is the function of a clutch? The main function of a clutch is to engage and disengage the transmission of an automobile or any other thing, right, from the engine, right? Now, why it is required? It is required because the engine cannot be stopped suddenly. Okay? The engine will continuously keep on running. Okay? It will have some RPM, it will have some constant RPM, in fact, right? Constant RPM in the sense on it depends on how much fuel you are supplying, how much accelerator you have pressed. Okay? The engine will not stop running, right? Continuous running, continuous running, right? So engine will continuously run, right? Now the transmission system which it transfers the power from the engine to different parts, right? For example, in your car, in your vehicle, the engine is situated at a one place, generally on the front side, right, below the bonnet, right? And the transmission part, it actually helps in transmitting the power to the wheels. The transmission of the system, the transmission of the car, it helps in transferring the power to the power from the engine to the wheels, right? So that is the role of a transmission and the engine. Where will be the gearbox situated? The gearbox will be situated in the transmission. Okay, the gearbox will be situated in the transmission assembly. Okay, now many a times, like for example, while loading, while disloading, right, many times we will require to stop the vehicle. For example, if some passengers wants to come in, what you have to do? You have to stop the vehicle, right? There are two. If you don't stop the engine, if you don't switch it off, take a date, the engine is going to continuously run. Suppose you are in traffic, you have to stop the vehicle, right? Suppose somebody wants to come in, you have to stop the vehicle, right? You cannot switch on the engine, switch on and off the engine each and every time, right? That will cause problem in the engine, right? Your spark plug or whatever ignition system, it will get weared out very fast, right? You cannot do that. So what does the clutch do? The clutch, it disengages the engine from the transmission shaft so that you can load or unload anytime you require. So you just press the clutch. Okay, you just press the clutch. What will happen? The clutch will help to disengage the transmission system from the engine, right? So engine will continuously run, it will keep on running, but the transmission shaft, if you engage the clutch, the transmission system will come to a halt, right? If you apply the brake, the transmission system will come to a halt, right? So we can simply say a clutch, अभी बहुत ज़्यादा time नहीं दे सकते हैं, right, in explanation. Otherwise 15-20 minutes could have been given how exactly each and everything's work, but we don't have the luxury of time, right? So a clutch is a machine element whose function is to disengage and engage a driver and driven shaft, right? The driver shaft, that is attached with the engine, and driven shaft, that is attached with the transmission system. Clutch allows without stopping the prime mover. Without stopping the prime mover means that is the engine. Clutch allows the driven machinery to start and stop frequently without stopping the prime mover. Right? This is the main function of the clutch. Okay. Now the clutches are designed. There are two theories on the basis of which clutches are designed: the uniform pressure theory, and you have uniform wear theory. Uniform pressure theory and uniform wear theory. Uniform pressure theory is for new clutches. Uniform pressure theory is for new clutches. So what does uniform pressure theory tells us? It says that the pressure over the clutch plate, okay, the pressure over the clutch plate will be, it tells that the pressure over the clutch plate will be uniform. So this is a clutch plate. You can see this is the front view, this is the side view, right? There will be two plates, two clutch plates. There will be two clutch plates like this, which will be pressed against each other with some load W. There will be two clutch plates which will be pressed against each other, right? The clutch plates are generally hollow in nature, right? Because nearer to the center, there will be not much torque. Friction, though it is developed, right? Friction, though it is developed, it is again designing point of view. The more you come closer to the radius, to the center, the perpendicular distance will keep on reducing, right? So you're not will not achieve much of frictional torque, right? So what is done instead? So maximum friction material is kept, right? You're reducing the cost this way. The friction material is kept away from the center. The friction material is kept away from the center. Okay. So they will be pressed against each other. So some amount of pressure will be developed here. 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 On the basis of this pressure, okay, what is said, there are two theories developed. One is the uniform pressure theory and one is a uniform wear theory, right? So let us first understand what is uniform pressure theory. So uniform pressure theory says that the pressure will be uniform throughout the friction surface. Why so? Because the clutch is new, there is no wear and tear, because of the less wear and tear, it is same everywhere. The clutch is same everywhere, right? Even if you take the inner radius or the outer radius, the total the composition of the friction lining will be same. You take the inner radius or the outer radius, the total composition of the friction lining will be same, right? Okay, बहुत ज़्यादा will not get into details. Okay, we'll just try to see how to solve the problem and few objective questions that can be asked. Okay. So if W is the total operating force by all the actuating springs, there will be springs who are applying this force. There are springs. अभी construction उसमें नहीं जाते हैं, ठीक है? R1 is the inner radius, R2 is the outer radius, right? You have to remember three formulas here. Right? First is the mean radius, or it is also called as friction radius. Mean radius or also friction radius. Or mean radius. It is given as 2 by 3 R2 cube minus R1 cube divided by R2 square minus R1 square. Right? So how is the load given as? The load is given by total actuating load. The spring load is given by pressure. If pressure is P, देखिए इधर सब everybody see, if the pressure is P, what is the pressure? Pressure is P. You can see this is the pressure. Pressure is P. So what will be the load? Load is equal to pressure multiplied by area. What will be the area? Can I say area is nothing else but R2 square minus R1 square? Pressure is nothing else but the area is nothing else but R2 square minus R1 square. Right? This is the area I'm talking about. Because this is a hollow. Right? This is a hollow. R2 square pi R2 square minus R1 square. This is the area I'm talking about. Right? So what is the final torque? What is the final torque? This is the final torque. The final torque is equal to mu, that is the coefficient of friction or the friction lining. Total load, this is the load, and this is the torque. Frictional torque. Load and the frictional torque. Okay. If question solve karta, then I think you'll be able to understand. Let us solve a question, then you'll be able to understand. All of you solve this question. Okay, I'll at least give you the basic formulas so that you don't have to refer it to the previous slide. Okay. So what is W? W is the total pressure, total force, pressure multiplied by area, that is 2 pi, 2 pi, pi R2 square minus R1 square. The total load. What is the value of mean radius or friction radius? 2 by 3. These formulas are directly asked. Square cube, sorry. These formulas are directly asked. And what is the frictional torque? Frictional torque is equal to mu into Rm into W. So these are the three formulas. Similarly, you'll have few formulas for uniform wear theory also, and then some conceptual questions, 1-2 questions conceptual. See, yes, this is a very good question. I'll tell you, this unit conversion you should know. Okay, megapascal, If you write it, if you write it as, Newton per meter square, you have to take it 10 to the power 6. But the best thing is that 1 megapascal can directly be written as 1 Newton per mm square. Okay, please note this down. It's very useful. 1 megapascal is equal to 1 Newton per mm square. So you see the dimensions are given in millimeter. The dimensions are given in millimeter, right? So you need not bother to convert it into meter and again multiplied by 10 by 6. You can directly use that way. So that is why it is very important. This is one of the most important concept in strength of materials, right? In fact, more important than the formula for stress. If you know this, then a lot many things will get simplified. So this is general advice, okay, not just for machine design or for the particular subject. Okay, if you are preparing, it's not just for the HL exam. It is general practice. If you are aspiring to get into PSU, to crack gate or any other PSU exams, to if you are aspiring to clear this HL exam, right? So you should always focus on the units. Okay, focusing on the units will actually help you. Yes. So in Newton meter, how much it is going to be? Very nice. In Newton meter, how much it is going to be? 196, right? 196 Newton meter. So directly हम देखते हैं. Very nice. So I can write TF, frictional torque, is equal to mu Rm. What is the value of Rm? 2 by 3 R2 square, R2 cube minus R1 cube divided by R2 square minus R1 square into W. So when I multiply Rm and W, we can clearly see that the denominator of Rm will get cancelled out, right? This will get cancelled out. My charger, just hold on. Right, so I can directly write it as 2 by 3 R2 cube minus R1 cube into pressure P into pi. So this portion and this portion has got cancelled out. If I'm directly writing it, mu is given as how much? What is the value of mu? 0.4 into 2 by 3. Now radius. Not many people make mistake here. Okay, this is given as diameter, right? So radius will be half of this. So 50 cube minus 20 cube into pressure is 2 megapascal, 2 Newton per mm square I can write. Okay, if I'm writing mm square, it will be okay. It will be okay. The answer will be in Newton mm, right? Newton mm, because this is cube, now 50 mm cube. So mm cube, mm square. So finally there will be 1 mm left out into pi. Let us try to calculate this. 0.4 into 2 divided by 3 into 50 to the power 3 minus 20 to the power 3 into 2, right? Into pi, into pi. It is coming out to be 196.034, right? So it is coming out 196.035 Newton mm. ठीक है, ये बहुत important है, Newton mm. So if you convert it into meter, 196 Newton meter. So I hope you got to know how to use this formula. Very simple, right? बहुत ज़्यादा concept है नहीं. Directly you have to use the formula, right? Yes, remembering the formula is definitely a task. ठीक है, you have to remember. There is no other way. Right? We're not going through the derivation part. We're not going through the derivation part. We're just learning the formulas here. Okay. So similarly, you have national uniform wear theory. This is for old classes, right? So what happens as the clutch keeps on getting used and used and used and used, right? It will get weird. It will get weird. I'm assuming that the wear is uniform. And what I'm assuming is the wear is uniform, right? Now tell me, will the wear actually be uniform? No. Why? Because if you see, we know that velocity is equal to omega r. Velocity is equal to omega r, right? Omega is constant, right? So you can see at lower radius, if you have v1, at higher radius, if you have v2, so definitely v2 is going greater than v1. Lower radius is v1, right? Because velocity is directly proportional to radius. So definitely v2 is going to be v1. So at higher speed, definitely the wear will be more. At higher speed, wear will be more, right? This is the actual condition. But what I am doing is I'm assuming uniform wear. So if I want to assume uniform wear, right? So how is that possible? That is only possible if the pressure at the outer surface is less. Pressure at the outer radius is less, pressure at the inner radius is more. Okay? Pressure at the inner radius is more, pressure at the outer radius is less. So why it is assumed like this, we'll not go into those details for now. Okay, for now we are not going into those details, right? But this is how it is, right? This is how it is. The pressure at the outer radius is less, pressure at the inner radius is more. So that the multiplication of pressure and velocity remains constant. So multiplication of pressure and velocity remains constant. So what it helps? It helps in a uniform wear. It helps in a uniform way. It helps in a uniform way, right? Again, velocity is equal to omega r. Again, velocity is equal to omega r. All of us know velocity is equal to omega r. So in place of velocity, I'm writing r. So multiplication of pressure and radius, P1 into R1, pressure at inner radius multiplied by inner radius, P2 R2 is pressure at outer radius multiplied by the outer radius is equal to C. Okay? The C is important because we are going to use it in the formula. The C is important for the C, right? So what is now the total load? Total load on the, this is the total load by the springs, actuating springs. Total load on the clutch is this much, 2 pi C R2 minus R1. So this is the mean radius, friction radius, or mean radius friction radius or mean radius. And what is this? This is the frictional torque. The expression for mean radius is simple. Here, in case of uniform wear theory, that is R1 plus R2 divided by 2. R1 plus R2 divided by 2. Now all of you, can you tell me which will apply? Just use what is X here. Means X here in the sense at any radius X. Okay, at any radius X. For example, let me say this is the center. If I am taking this X, suppose the question can be framed in three ways, right? You are given the pressure at the outer radius. You might be given pressure at the inner radius, or you might be given pressure at any distance x or any radius r from the center. So you have to calculate C. Only when you will calculate C, you'll be able to find out the total load W. Right? In place of X, it would have been better if I write it R at any radius R. This is better actually. Okay, if I write it as R, it will be better. Right? So if you calculate C, only then you'll be able to calculate W. So C is equal to pressure multiplied by the radius at the pressure. Radius at which the pressure is given. So you might be given P2 and R2, you might be given P1 and R1, or you might be given P and R. You should be able to calculate W. So the formula is simple here. We are not going, otherwise everything else is same. Otherwise everything else is same. No, you will not face any problem. You will not face any problem. Otherwise everything else is same. Like the question we have done. Okay. A simple question to you, which one will be out of uniform wear theory and out of uniform pressure theory, which will you think give us which do you think will give us more torque, more frictional torque? Which theory do you think will give us more frictional torque? I want answer, both of you. Which theory do you think will give us more torque? Is it uniform wear theory? And you can answer it from your common sense. You can answer it from your common sense without even going through the formulas, nothing else, nothing. You can answer it from your common sense. Which theory should give you? Why do you think so, Naveen? I want to know your version of common sense. Why do you think so? But I have not done. But we have not seen if pressure is more or less. Okay, we have not compared. We don't know what is the pressure here. We have not compared the pressure here and here. We just know that pressure at the inner radius of the uniform theory. Okay, to some extent you use the logic, but your logic is not correct. In uniform wear theory, the pressure at the inner radius is greater than pressure at the outer radius. This is what we know. Right? Here P1, P2, we know that P1 is greater than P2. But do we know that P1 is greater than P? If the pressure is P here, do we know this? No, that is not necessary, right? It could be different for different application, right? Now, why I said logical, okay? Why I said logical, okay? You see, new clutch. You have a new clutch and you have an old clutch. You have a new clutch and you have an old clutch. Which do you think will give you more friction torque? You have a new clutch and you have an old clutch. Which will give, this is the logic I actually, because why I am telling you, so that you can remember it this way, right? It is a new clutch. Definitely the new clutch will give you more friction, right? So that is why that is how you can actually keep it in your mind. Uniform pressure theory will give you more frictional torque than the uniform wear theory, right? So why two theories are required? Why two theories are required? If you apply the uniform pressure theory, on an old clutch, the theory will overestimate the old clutch. The theory will overestimate the old clutch. The theory will say that this old clutch can give you 100 Newton meter of torque, but in actual, it will not be able to give that 100 Newton meter. Right? Definitely, it has become old, it has weared out. So might be it is giving somewhere around 70, 60, 70, right? Newton meter. The new theory, if you apply new theory to old clutch, what will you say new theory? It is going to give you 100. So ultimately, if you apply that clutch to your system, what is going to happen? There will be a slip. If you apply to a system, if you put it in your system, right, the old clutch will slip, right? So that is why okay, there are two different theories. One for the old clutches, if the clutch has become old, if you want to put it somewhere, right, if you want to use the clutch plate somewhere, you are going to use the uniform wear theory, that old clutch. Otherwise, for uniform pressure theory for the new clutch. Okay, so this you need to remember, right? This you need to remember. Okay, so there can be multi-plate clutch. ऑब्जेक्टिव क्वेश्चन यहाँ से बन सकते हैं, ठीक है. देयर कैन बी मल्टीप्लेट क्लच, ठीक है. मल्टीप्लेट क्लच, we'll see where multiplate clutch are used exactly, right? So you can see 1 2 3 4 5, ठीक है. There are 5 clutch plates, ठीक है. 1 3 5 are driving flange, driving, 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 driving. Then you have 4 and 5 are driven, 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 right? So if N1 is the number of driving flanges, N2 is the number of driven flanges, this will be given in your question. Total number of contact surface, you can see the total number of contact surface will be, how many contact surface are there here? Can you see this is one contact surface, this is one contact surface, this is one contact surface, this is one contact surface. So how many contact surface are there? 1 2 3 4, right? It will be given by total number of contact surface will be given by N1 plus N2 minus 1. It is summation of driving flanges plus driven flanges minus 1, right? So here you see there was only one contact. We have written this formula for only one contact surface. There can be multiple contact surface, right? So if N is equal to total number of contact surface, so uniform pressure theory, all the formulas will be same. All the formulas will be same. Only the torque will become N into mu Rm W, right? Torque is equal to N mu Rm W. The value of Rm will be same. Rm is equal to how much? Here R1 plus R2 divided by 2. What is here? Rm? Rm is equal to 2 by 3 R2 cube minus R1 cube divided by R2 square minus R1 square. Right? What is W here? W is equal to pressure multiplied by area. And what is W here? We have seen it in last slide, right? 2 pi C R2 minus R. So this is exactly what you have to do. Okay, so यहाँ से एक objective question बन सकता है, right? Objective. Now this will not be asked. This portion will not be asked, but this has been asked earlier in engineering service. So this concept you can see. Okay, if there are n number of driving flanges, n1 and n2 driving and driven flanges, so total number of contact surface will be n1 plus n2 minus 2. Okay, so you have done this problem. Now let us come to centrifugal clutch. So before centrifugal clutch, let us see where exactly we are going to use single plate clutch and multi-plate clutch. So single plate clutch will be used where space is more, where the space is more, you have more space, right? So what you can do, you can put in big clutches, For example, trucks, tractors, right? Heavy vehicles, more space is available, right? You can put single plate clutch. So what is the difference? Single plate clutches means the clutch itself will be big. The clutch plate will be big in size. So the clutch plate will be big in size. Okay, but in your cars, two-wheelers, right, where you have compact space, you'll not be able to use big clutches to achieve same amount of braking torque. Okay, or the same amount of torque. Better not to say braking torque, the same amount of frictional torque, right? What you have to do, you have to use small clutches multiple number of times. Small clutches multiple number of times, right? So what will happen? The friction radius will reduce. Rm, the value of Rm will get reduced. You can see the value of Rm will get reduced because R2 and R1 will get reduced, but you're multiplying it with N so that it compensates. So you're multiplying with N, it is a number of contact surface that will compensate. Okay, is it clear? Is it clear? Okay, very nice. Okay. So we'll talk about two types of clutches are remaining now. That is the centrifugal clutch and cone clutch, centrifugal clutch and cone clutch. So let us try to understand. ठीक है, यहाँ पर भी बस understanding ही की ज़रूरत है. Numericals, I am not very sure they will be asking numericals, but objective questions on the formulas might be asked. Simple means they will not put in numerical value, but they will twist and turn and ask you the algebraic formula. Okay, let us try to understand. Let us try to understand here. RD is the radius of the drum. So this is the drum, you can see. This is the drum. So RD is the radius of the drum. R is the radius of the shoe at the engaged position. RG is the radius of the shoe at the engaged position. Now there is a slight difference between radius of the drum and radius of the shoe, right? So let me take the example here. Suppose this is the shoe at the engaged position, right? So the shoe will have some center. So this is basically RG. Radius of the shoe at the engaged position. From here, if you calculate, this is radius of the shoe at the engaged position, right? But if you see the radius of the drum, it will be slightly different. The radius of the drum will be slightly different, slightly more in fact. This is nothing else but the radius of the drum. Right? Are you able to understand? I'll use the capital. Right? You can see there is a slight difference between the radius of the shoe at the engaged position. Engaged means otherwise the shoe will not be engaged. At very low speed, the shoe will not be engaged, right? Because of the spring force, the shoe will not be engaged. Now, as soon as we are going to study, we are going to see this, we are going to see the mechanism. Let us first understand what are the different terminologies, then we will be able to understand, right? The equation properly. What is the concept? So M is equal to the mass of each shoe. M is equal to the mass of each shoe. Z is equal to total number of shoes. There can be 2 or 4 shoes, right? F is the centrifugal force, F is equal to spring force, W1 speed at which engagement starts, W2 speed at which is the running speed. Okay? Let us try to understand what exactly is happening here. Let us try to understand what exactly is happening here. Let us try to understand what exactly is happening here. Let us try to understand what exactly is happening here. Now, let me say the engine starts moving. Let me say the engine starts moving. As soon as the engine starts moving, the clutch will also start moving. The clutch will also start moving, right? As soon as the clutch starts moving, we can see the shoe will rotate and there will be some amount of centrifugal force. Some amount of centrifugal force. Some amount of centrifugal force. Right? So what will happen to the shoe? Shoe will start coming out. The shoe will start coming out. So the spring is getting extended. The spring is getting extended. The spring will also apply some spring force. The spring will also apply some spring force. Now, as you keep on increasing the speed, the centrifugal force will keep on increasing. The centrifugal force will keep on increasing. So what will happen to the shoe? The shoe will keep on moving outwards and outwards and outwards and outwards. And at some speed, let me say the omega 1, at some angular speed, let me say omega 1, the shoe get engaged. The shoe get engaged to the drum. 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 Okay, so what is omega 1? Omega 1 is the speed at which the engagement starts. Omega 1 is the speed at which engagement starts. Right? So what is the normal reaction? It is just engaged. It is just engaged. So at this point, when engagement starts, the normal reaction will be 0. It just started the engagement, so initially the normal reaction will be 0. Now, as soon as the speed, it will keep on increasing. The speed will keep on increasing. As the speed keeps on increasing, what will happen? The centrifugal force will keep on increasing. The centrifugal force will keep on increasing. As the speed increases, the centrifugal force will keep on increasing. But will the spring force be able to keep? But will the spring force be able to keep on increasing? No. Why no? Because the extension of the spring is limited. The extension of the spring. Now the shoe cannot move out because it is now restricted by the drum. It is restricted by the drum, so the shoe cannot move out now any further. So what will happen? What will happen? The spring force after omega 1, it will remain constant. After omega 1, it will remain constant. Right? So what I can write? So what has happened here? What has happened here at engagement, when the engagement starts? When engagement starts, when engagement starts, I can say the centrifugal force is equal to spring force. When just the engagement starts, centrifugal force is equal to spring force. What is centrifugal force? Can I say the centrifugal force is equal to mass of the shoe, radius of the shoe at the engaged position, omega 1 square. This is equal to the spring force. When the engagement starts, this is equal to the spring force. Right? Now, as the speed keeps on increasing, as the speed keeps on increasing, what is going to happen? As the speed keeps on increasing, what is going to happen? The F, centrifugal force, will keep on increasing, but Fs is equal to constant. That is equal to mRg omega 1 square. Fs cannot increase beyond this point. Fs cannot increase beyond this point. So when I'm running at W2, I hope all of you can see my screen. So when I'm running at W2, at speed W2, at running speed, W2, so what has happened? Come. At running speed W2, what is happening? This is the drum. This is the shoe, right? So you have some centrifugal force F. What is F? The value of F is equal to m omega 2 square Rg, right? You have some spring force Fs. What is the spring force? Spring force is equal to m, because it has remained constant after engagement, right? So what will happen, because the centrifugal force is more than the spring force, what will happen? A normal reaction will develop in the direction of spring force. M Rg omega 2 square minus omega 1 square. So because of the normal reaction, what will happen? Because of the normal reaction, a friction force will get developed. A friction force will develop. Friction F is equal to mu into N, mu m Rg omega 2 square minus omega 1 square, right? So friction, where it is developing, friction is developing in the drum. Friction is developing in the drum. Friction is developing in the drum, right? So what will be the frictional torque? This is important. This is equal to friction. Friction multiplied by radius of the drum. Friction multiplied by radius of the drum, that is equal to mu m Rg into Rd into omega 2 square minus omega 1 square. So here the derivation was more important. That's why I have derived it for you. Okay, understanding, because it's simply, if I have given you the formula, you couldn't have understood what exactly is happening, why it is written, because questions that are being asked is not numerical in nature, but actually algebraic in nature. Okay, this question might be asked, small twist they will give. Okay, you should be able to now figure it out yourself. Is it clear to all of you? Is it clear to all of you? Yes? Okay, great, great. Okay. So where are centrifugal clutch used? Centrifugal clutch are used at mopeds, lawn mowers, right? What happens? How exactly centrifugal clutch happens, right? If you have ever seen a moped, okay, or if you get to have if you get the opportunity to go through, so what will happen initially when the engine starts? Initially, when the engine starts, okay, the vehicle will not start moving. You don't have clutch. You don't have clutch there. Okay? You don't have any external clutch in mopeds, right? So when the engine starts, initially the moped will not start moving. Only when you start slowly increase the speed. How you will increase the speed? That is by pressing the accelerator. How you are going to increase the speed? That is by pressing the accelerator. So once you keep on increasing the speed, at a certain speed, the clutch will get engaged, right? The shoe of the clutch will get engaged, and after that, if you still increase the speed, the moped will start moving forward. The moped will start moving forward. Again, if you apply brake and if you just bring your accelerator down to 0, again the engine will be on, but the moped will not be moving, right? Only when you again increase the speed of the engine by putting on the accelerator at a certain at a certain point of the accelerator, the clutch will get engaged, and after that it will start moving. So this is how it happens. Okay, this is how it happens. Now there is another type of clutch which is known as conical clutch. We'll just go through the formula. Okay, where are conical clutch used? They're used in machine tools. Okay, machine tools equations आते हैं. These questions from this classification is being asked. Okay, class where single plate clutch is used, where multi plate clutch is used, where conical clutch is used, where centrifugal clutch is used. Please remember this slide at least. Okay, so conical clutch, it will look like cone, right? It is generally used in machine tools. Perfect alignment is required. Take a perfect alignment. If you don't have the perfect alignment, take a perfect alignment is required. Otherwise, you will not be able to engage this clutch. Perfect alignment is required. Okay. So here you can see 2 alpha is the cone angle. 2 alpha is nothing else but the cone angle, right? We know what is friction angle. Okay, we can write friction angle phi as tan inverse mu. Tan inverse mu is nothing else but friction angle, right? For safe design, this is a question that is asked in objective. For safe design, the half cone angle, what is alpha? Alpha is half cone angle, because 2 alpha is cone angle, so alpha becomes half cone angle. Half cone angle should be greater than the friction angle, right? If the half cone angle is less than the friction angle, these engagements become very hard, difficult, and it is called graving. What is called as? It is called as graving. Okay, so this is the formula I was talking about. This formula you have to remember. Okay, everything is same, mu w rm. Okay, everything is same, only that you will have to divide it by sine half of cone angle. Torque is equal to torque, for the formula is equal to mu w rm. This is same as that of earlier clutches we have seen, only divided by sine alpha, where alpha is equal to half, sorry, cone angle, half cone angle, right? And then there is, you can use the either uniform pressure theory or you can use uniform wear theory. I hope it is clear, simple, nothing too much, nothing much to worry about, right? So we have done with 2 chapters, that is uh, clutches and brakes today. We have done with 2 chapters, that is clutches and brakes today, right? So any doubt, tell me throughout the lecture. Throughout the lecture, if you have any doubt anywhere, you can tell me. If you have any doubt anywhere, you can tell me. Throughout the lectures, anywhere, any doubt, you can tell me. Yes. So otherwise, your machine design is completed. We have done in a very short period of time. You have done theories of failures. You have done design again dynamic loading, right? Then you have done riveted, bolted, and welded joints. We have done bearings. We have done brakes, gears, and clutches. The last one, that is springs, you have to go through the YouTube video that is already available from IIT and Gate classes. So no more new concepts in machine design. Just revise whatever has been taught in class. That is more than sufficient to actually get you in. Least possible time is the maximum that could have been shared. Least possible time, that is the maximum that could have been shared. Any doubt? No? Okay, just revise well, revise well. Okay, I wish you best wishes from machine design point of view. I wish you best wishes from machine design point of view. We'll be starting theory of machines shortly. We'll be starting theory of machines shortly. Okay, thank you all of you. Thank you. I'll end the meeting.